Hi guys, this is homework help for the average acceleration and velocity time graphing problems, aka the rocket sled worksheet. The equations that will be helpful for this one are the average acceleration equation, including a equals final velocity minus initial velocity over time, and its other form, final velocity equals initial velocity plus acceleration times time. Okay, so when we do any kind of physics problems, we want to start with finding the givens. So in our example, Grace is driving her Corvette at 30 meters per second when a ball rolls out into the street in front of her car. Grace slams on the brakes and comes to a stop in 3 seconds. What was the acceleration of Grace's car? Okay, so first of all, we're going to pull all the numbers out that we can. So we see that she's driving her Corvette at 30 meters per second initially, and so that's going to be my VI. Or VO. By the way, VI is the same thing as VO, and you can use whichever notation you prefer. Okay, then Grace slams on the brakes and comes to a stop. So that means VF is 0. That's one of those givens that's kind of hidden. You have to look for wording like started from rest or came to a stop. Okay, they tell us that it takes her 3 seconds to do so. And then we want to know what is the acceleration of Grace's car. So A is our unknown. So based on this information, this list of givens, and we go back and look at our equations, it makes the most sense to use the equation where A is already by itself. So we're going to use average acceleration equals a change in velocity over change in time. VF was 0. VI or V naught was 30. And then put that over time of 3 seconds, and I get a negative 10 meters per second squared, and that is my final answer. You don't have to adjust for sig figs. 30 only had one sig fig in it, and so does 10. Okay. If we skip down a little bit, I always have questions on number 2. So let's just look at the givens a little bit. They give you a lot of information, and so sometimes it's hard to figure out which numbers to pull. So our rocket power sled is starting from rest, can reach a speed of 444 meters per second in 1.8 seconds, and then can be brought to a stop again in 2.14 seconds. So we have both speeding up to acceleration, or to the greatest speed, and stopping from that greatest speed. So in part A, we want to go for speeding up from a stop to max speed. So that means initial velocity is 0. Final velocity is 444 meters per second. And delta t is 1.80 seconds, or the time it took to speed up. A is our unknown. And then on part B, we want to know when braking from max speed to a stop. So that means VI now is going to be 444. We start at max speed and we come to a stop, so VF is 0. And they gave us a different time for that. It was 2.14 seconds. And then we're looking for A. Okay, so a lot of information, but you can wade through it and just use the information appropriate for that question. And then the other one I want to look at is this one on the back, because it tends to throw people a little bit, number 4. So it says to draw the velocity time graph to match each of the position time graphs below. So basically what they did is they gave you a position graph, and you need to draw the corresponding velocity graph, okay? So on the first one, when you have a curve on that position time graph, and you know that slope is equal to velocity on a position time graph, a curve means the slope is not constant. In other words, the velocity is changing. This curve that they have for us here is getting steeper, so that means our object is speeding up. So if we say our velocities are positive and then the origin represents 0 meters per second, we have a positive slope that is increasing. So in our velocity graph, we want to show a positive velocity that is increasing. Okay? So break the graphs into sections and then figure it out just in sections for the next part, for B and for C. And as always, just reach out if you have questions and you need help from your